In this video, I am going to show you how a camera works. We're going to talk about the three main parts of the camera and what they do when you're taking photographs. The three main parts of the camera are the aperture, the shutter, and the ISO. Understanding how these components work will make it easy for you to make photographs that look the way that you want them to look. When you put a camera on auto, the camera is just a machine, right? So you can't really make any creative decisions. But if you turn the camera to manual mode, you can adjust these three things, the aperture, the shutter, and the ISO, so that you can make a picture that looks the way that you want it to look. It will give you more creative freedom over your images. Photography in general is all about the light. All parts of the camera exist to allow the right amount of light into the camera to create an image. Each camera is a little bit different, but they all have the same parts, and all of those parts control the light. The first part, the shutter, controls the length of time that the light is allowed to enter the camera. The second part, the aperture, controls the intensity or how much light enters the camera. The ISO controls your camera's sensitivity to light. We are going to talk about each part individually so that you understand how they work alone, and then later on we'll talk about how they work together to make a creative image. The first part that we're going to talk about is the shutter. The shutter is a controller of time. Its function is to open for a specific length of time, allowing light into your camera, and then it closes, blocking the light out of your camera. In a digital camera, when it opens, the light comes in and hits the sensor and creates an image. Back in the day when we were using film, the shutter would open and it would actually hit the film that was light sensitive, and it would make the image on the film. The length of time is usually brief, only a fraction of a second. Modern cameras use a system of two curtains working together. When you press the shutter button, one curtain opens to allow the light to enter and the other one closes behind it. On the bottom here, you see a visual of that. But what I'm going to do right now is I'm going to show you. I'm going to show you what the shutter looks like. So what I actually have here is an old film camera, right? Pretty cool. And the reason I'm going to use an old film camera to show you is because you can actually open the back of the old film camera, and this is where we would have put the film. We would put the film here, and we would have pulled it out and put it across here and into this little thing. This square right here is your shutter. Watch what happens when I press the button to take a picture. When I press a button to take a picture, it opens and closes, right? Opens, closes, right? That's your shutter. And you can see, watch, I'll put my hand over here. Hello. Whatever is in front of the lens, right? When you press the button, it opens the shutter, and whatever's in front of the lens appears in the back. See? Pretty cool, huh? That's a basic idea of your shutter. Okay, let's go back to our presentation and keep talking about what a shutter does. The main purpose of the shutter is to control the perception of motion in your image. You'll understand what that means a little more in just a minute. The length of time that the shutter is open is referred to as the shutter speed. Shutters can range from 1/4000th of a second, so they could be opened super fast, to 30 seconds or a minute. They could be open for a whole minute, and I'll show you in a minute why we might want to do that. Okay, now if you want to open your shutter for a very long time, like a second, 2 seconds, 3 seconds, 5 seconds, something like that, you're going to create a blurred motion image. anything that moves in front of your camera is going to be blurry. The way that the water in this example image is blurry. You see that? Long shutter speeds, though, make it hard to hand-hold your camera. They can result in unwanted motions during the exposure called camera shake. If I did not have this camera on a tripod and I had a very long shutter, I would move, my hands would move, I would be breathing, everything would be moving, and then everything in the picture would be blurry. When you're doing a really good blurred motion shot, the only thing that should be blurry is whatever is moving in front of your camera. See, notice again in our example picture how all the trees, the rocks, everything else is very stable and very clear and not blurry, and the only thing that's blurry is the water. Okay, so to get rid of a blurred motion or to get rid of camera shake, you use a tripod, right? So blurred motion is the first type of picture you can take with a long shutter speed. The second type of picture that your shutter controls is a frozen motion picture. This is what you see most often. You usually see a picture where action is stopped in time, like, you know, the guy catching the football or whatever. So fast shutters, a duration of 1/250th of a second or faster, will freeze the motion in your image. This stops a moment in time, right? The important thing to note about timing, when you trip the shutter, when you press the button, the viewfinder actually goes black. It's during this time of blackout that the actual exposure is made. So if you see the photo through the viewfinder instead of seeing like a second of black, then you've actually missed the picture. Okay, now I want to show you again what that means. So here we have right here, see this number? And when I move this dial on my film camera, that number changes. Okay, 2,000 is my fastest shutter. What that means is when I press this button, let me show you, this shutter is going to be open for 2,000ths of a second, really quick. See that? You can barely see it opening, right? Now, this is the viewfinder. Look at the viewfinder when I press the button. It goes black. That's what I'm talking about in that last slide, right? Now, if I change this from 2,000, we'll go to 90, right? That's 90ths of a second, right? Watch the difference. Now I can actually see through the camera, right? That's 90ths of a second. Let's change it again. Where's my dial? There it is. 10. That's a 10th of a second. Wow, right? Let's change it again. Now, let's get crazy with it. If I keep going, 1 with the little quotes, that is 1 second. 1 Mississippi. 1 second, right? It goes beyond that. 2 seconds, 8 seconds, 30 seconds, right? Then it's got this really cool thing called bulb. I'm not going to do a 30-second exposure. That would be weird to just sit here in a video for 30 seconds and not do anything. Anyhow, bulb. Watch what bulb does, okay? Bulb, when you press the button, takes the picture. But if I press and hold the button, it stays open for as long as I am holding this button down. Boom. I'll tell you why you might want to do that. Let's go back to our presentation. This is why you might want to do that. See this picture over here on the left? Those are star trails. If you set up your camera at night in a very dark place where the only light you're seeing is from the stars, and you leave your shutter open for an extended period of time, I'm talking like minutes, maybe 10 minutes, maybe 15 minutes, I don't know, you actually capture the movement of the stars. It's actually the movement of the Earth, if you want to get really technical. If you want to look more into astrophotography, the way to get the actual circle is to find the North Star and put him right in the middle, and then all those other stars rotate around it. So that's why you might want like an extended, that's only one example, but an extended shutter speed, right? Now let's look at this picture on the right. This is the same photograph at different shutter speeds. So the first one is 1/500th of a second. It's stopping those little water droplets, and you see them as little water droplets. At 1/250th of a second, they start to blur a bit. At 1/60th of a second, they blur even more, and at 1/30th of a second, they are almost lines. Right? So it's almost like you don't have just a stopped motion or just a blurred motion picture. You have steps in between as well. So how much do you want it to blur? How much do you want it to stop? That's another creative decision you can make when you understand how to use your camera. This is your shutter cheat sheet. So over here on the left, you see that we have a timeline, and it says 1/8 thousandths of a second. That's really super fast. When you have a really super fast shutter speed like that, the shorter the shutter stays open, the less light that strikes the image. It freezes your motion, and you don't have to worry about that last one right now because you won't understand what that means. On the other end of things, on the right hand side, if you have a 30-second shutter speed, you have a long shutter. Your shutter's open for a long amount of time. There's a lot of light that's coming in, obviously, because it's open for 30 seconds, and it shows or blurs your motion. That is part one. Oops, sorry. The shutter, okay? That's the first part of your camera. This next part of your camera is called the aperture. The aperture is the controller of intensity, also known as how much light is let into your camera. The aperture is a resizable opening through which the light passes while the shutter is open. The aperture is also referred to as the f-stop. The aperture is not as straightforward as the shutter. It takes a little more to understand it. So the shutter, you have 8/1000ths of a second is open super quickly, or 1 second is open longer, okay? If you notice here at the bottom, you have an aperture all the way to the left, f2.8. f2.8 is wide open, okay? f4 closes down a little bit, f5.6 closes down even more, and then so on and so on and so on until you get to f16, and there's only a bit of an opening, okay? Let me show you again on an old camera. This is a lens that attaches to the end of your camera. It's a lens just like this one, right? This is an old lens because in the old lenses, the aperture is housed right here on this aperture ring. We'll talk about this in a second, but these numbers, 22, 16, 11, 8, 5.6, 4, 2.8, those are your f-stops or your aperture number. To change the aperture, you actually move this back and forth on the old school lens. On a new camera, on a digital camera, it's all inside, so you can't actually see anything. That's why I always use these old cameras to show you the parts. I'm the type of person who likes to know the why and be able to understand how something works, and then I can understand it better. So I think that maybe everybody else is like that too. Not always, but sometimes. Okay, so here we go. Can you see that little teeny dot in there? That's the aperture. Opens. That would be a 20, or this would be a 2.8, see, 2.8, closes down to a 22, right? So 22 is smaller, 2.8 is bigger, more, see, you can see, there's my hand, through the lens, okay? So one more time, smaller, bigger aperture, okay? Now, go back to our presentation here. This, to me, didn't make a lot of sense at first until I understood how the heck they get these numbers. So can you see on the bottom where it says f over 2.8? It's actually a fraction. So think about it this way. A 16th of the pi is smaller than half the pi. That's what helps me to understand how these apertures are, you know, written, or how we determine what they are. Okay? Moving on. What the aperture actually controls in your photograph is the depth of field. Depth of field is the amount of picture area in front of or behind your main subject that is in sharp focus. As the size of the aperture gets smaller, which is actually a bigger number, the depth of field increases or is more clear and less fuzzy. Think about portrait mode on your phone. Right? Those of us who have iPhones, and the portrait mode came out, and we were like, whoa, that's the coolest thing in the world. And I was all like, whoa, that's just a short depth of field I've been dealing with for, 20 some years, because I know photography. So here we have it. The first photograph you can take, if you know how to control your aperture, is a short depth of field. That means that the background is fuzzy. Right? I don't want to use the word blurry, because nothing's moving, nothing's blurring like your shutter speed. We're just kind of fuzzing out the background so you can't see it, so it's less distracting. To get a photograph like this, you need a larger opening, which is like an f1.4 or a 5.6. Different cameras have different ranges of aperture. You actually buy lenses based on which aperture settings you can get out of them. The opposite of that is a long depth of field, where everything in the picture is clear. Foreground, middle ground, background, everything is in focus, nothing is fuzzy. And to get that, you need a small aperture opening, which is an f11 through a 36. So here again are some examples. These little Eggmen over here. So we've got the 2.8, and look at him. You can see the one in the front. Everything else behind him blurs, right? And then an f5, and then you can kind of start to see the second guy, and then an f11. And you can see farther back, and an f22, and you can almost see out to the window. These are looking really pixelated on my iPad right now, so I apologize. They're not the greatest examples. But check out the chess piece picture. In that picture, we are using what's called a selective focus. So the first one is like a long depth of field where everything is in focus, foreground, middle ground, background. The one underneath it, we're focusing just on the king, and we're blurring the foreground and the background. If you have a very small aperture, you can do that, right? And then down here, this picture of the little girl fishing. First one, f1.4. Check out the grass in the background. It just becomes blurs of light and color, which is really cool. Also check out what it does to the water behind her. Kind of blurs those little, like, I don't know, reflections on the water. Looks really neat. And then a 2.8 is a bit clearer in the background. A 5.6, I can start to see some blades of grass here. 11, I see a lot of blades of grass, more detail, and the blurs, or the reflection in the water, turns into little spots now. And then the f16, you could see everything, foreground, middle ground, background. So that's the difference. Aperture scale is your aperture cheat sheet. At an f2.8 on the left-hand side, you have a large aperture, more light that comes in a shallow or a short depth of field. On the right-hand side, you have an f22, which is a small aperture, less light that comes in, and a long or deep depth of field. That's your aperture. The next one we're going to talk about is the ISO. Now, there is not part of your camera I can show you for the ISO, because back in the day when we used to shoot film, the ISO was actually in the film itself, not in the camera. Now that we are digital, the ISO is something that we have put inside the camera to determine how the sensor reads the light. So here's the idea behind ISO. ISO is your camera's sensitivity to the light. It's labeled 100, 200, 400, 800, 1600, 2400, and even higher. Lower numbers like 100 or 200 need more light to take a decent picture. So back in the day when you used to buy film to shoot your photographs, we used to have to think about where we were shooting and what we were shooting. So say, for instance, I'm gonna go outside on a nice sunny day and shoot some landscapes. I could then buy film at an ISO of 100 because I knew that there was going to be a lot of light in my situation and that the film would work well because there was a lot of light out there for my camera to capture. But higher numbers like 16 and 24, 100 don't need a lot of light. So say, for instance, I was going to shoot somewhere where it was low light, like it was dark. I wanted to do some night photography. I wanted to do some indoor photography. I would then need to purchase a roll of film that was a higher ISO because I would need it to capture the less light. The danger in that, though, is that the higher number is going to get you what we call noise. Noise in your image looks just awful. It's really, really crappy. So take a look on the left-hand side, and this is an ISO of 80. In an ISO of 80, I can see the letters on the page. I can see the numbers on the what is that? A tape measure. I can see the numbers on the tape measure. I can see the little lines. I can see all the details. As I go up, look at like 800, 1600, I start to lose detail. It becomes really noisy, grainy. That's what we call this, is noise or grain. And then when I'm all the way to 12,000, I can't see a thing. I can't see the text. I can't see the numbers. I can't even make out what that is. So the danger here is that you cannot fix noise. Okay? You can't fix that. There's no program, there's no editing, there's nothing I can do that can fix a noisy image. So knowing what your ISO is set to is really important. And I'll explain to you later why it even goes up that high if it takes crappy images. Sometimes it's all about balance and you have to up your ISO a bit to get your other settings correct, but that's something we'll get into later with the next presentation. So here's your ISO cheat sheet. At ISO 50, it is less sensitive to light, it will capture less light. You need more light for a good image and it's less noisy or grainy, so it's clear. At ISO 6400, you are more sensitive to the light, you will capture more light, less light is needed for a good exposure, and you have more grain or noise. Okay? That is your first presentation on how the camera works. Next presentation we'll talk about is how to take all three of these parts and put them together to make an image.